So lesson 1 in our two-part series is called the sugar sensation. And this was developed initially for an in-classroom activity, but we've recently adapted it for an at-home lesson plan. We've created a video here to introduce the topic. Hi, I'm Adam with Genome Sciences Education Outreach at the University of Washington, and I use they, them pronouns. So today, we've come up with an activity. It's essentially a taste test experiment to test and see how we perceive everybody's favorite substance, sugar. So we need sugar to survive, but how do we sense that from our tongue and into our brain, and what conditions change that? And so what we've done is we've adapted a lesson for at-home experimentation, where we're going to do an experiment essentially getting at the question of how different experiences can change the perception of a sugary substance. So you can imagine human ancestors, when they got a piece of fruit that tasted just absolutely fantastic, that was probably the sweetest thing that they ever got to experience within their lifetimes. And so getting the perfect apple or the perfect piece of fruit must have been an absolute delight. But then if you go along and you say, give one of those people one of these refined sugars, maybe some gummy bears, it's gonna blow their mind. I grew up on gummy bears. And so for me, just getting an apple just doesn't kind of cut it in many ways. So we've designed an experiment to kind of test this and to actually measure and quantify changes to sweetness perception after being kind of preconditioned with different sugary substances. So in the classroom, the teacher would prepare 4 different sugar solutions for solution A that would range from 0 molar, so just straight water, up to 1 molar sugar solution. Solution B, the one that is tasted after A, would all secretly be a 0.1 molar solution. So the students would travel from station to station, taste solution A, and then solution B, and rate the sweetness of solution A and B. So you can imagine that maybe a really high sugar solution for A would decrease their perception of solution B, even though solution B at every station is the exact same. And so the teacher would keep that secret until the very end when you're collecting the data, and then you can see that the sweetness of solution A had a dramatic impact on solution B. So the way we've adapted this for at home is that we've just cut down on the number of solution A's that we're creating. And so we're starting with a 0.3 molar sugar solution, which is the same as what any fruit juice would be. The students can use that fruit juice. And then we've created a video to help guide them through the process of making the dilutions. So you'd take that solution 1A, the high sugar solution, dilute it 1:1 to create 1B and 2B, the exact same. And then their final solution would be 2A, that's a 1:1 dilution of that middle concentration. And again, we made a video to help guide them through that. And then the students would then run the taste test of solution 1A, B, 2A, B with their household members, and then essentially record the sweetness. And I'm going to show you a video describing that procedure. Okay, so I'm ready to find my roommate and ask them to do the taste test for us. Okay, so this is my roommate Robbie, and he's going to rate the sweetness of the sugar solutions on a scale of 1 to 10, with 10 being the sweetest and 1 being not sweet at all. Are you ready, Robbie?
Oh, I'm so excited to do this experiment with you, Adam. I'm ready. Okay, so 1A, here we go. That's good. I give it an 8. Okay, so the next one, I believe this is 1B. Oh, well, it's a little sweet, but not very sweet. I'm gonna give it a 4. Okay, so 2A. Well, that practically tastes like water, so I give it a 2. All right, final solution. 2B. Well, that's pretty sweet. You know what? I'm gonna give it a 5. Great.
Okay, Robbie, thanks for participating, and Yeah, do you want to know the secret?
Well, yes, I do.
Okay, well, Robbie, 1B and 2B were actually the same concentration of sugar.
What? Oh, that's ridiculous. Well, they just tasted different. I don't get it.
So you can imagine the students might have a lot of fun conducting this taste test with their household members and then revealing at the end that solution B is the same. So when we look at Robbie's sweetness rating, the high sugar concentration decreased his perception of solution B, whereas the low sugar increased his perception of solution B. And so it's a mild effect. It's only a change of 1, but you can imagine it's kind of fun to be like, oh, those are actually the same. And so this data from Robbie actually looks pretty similar to the taste test that we did within our department, in which case here on the x-axis you can see an increasing concentration of solution A and then the perceived sweetness of solution B. And so this is with 25 different participants, and what we see is that these higher sugar concentrations desensitized the participants' rating of solution B. And decrease the sweetness rating rather significantly. So after the students kind of dive into the data that they've collected and comparing it to our data, we have a presentation to talk about what is sweet taste. And ultimately, sweet taste starts in the tongue and it ends in the brain. And so our tongues are covered with taste buds, and each of our taste buds has a different receptor that is specialized to sense a different chemical signal coming into our mouths. And so we have receptors that sense sweet, salty, bitter, and umami, which is kind of like a savory protein flavor. And so then our taste buds connect with neurons or signal to neurons that then transmit a signal into our brain, creating the experience of the flavor or the taste of something coming into our mouths. So when sugar hits our tongue, it's actually hitting the receptors on the taste bud, which then activates the taste bud, which then signals to the neuron and transmits a signal into the brain, telling our brain, yum, that was sweet, that tasted good. So one of the things that happens and what we're measuring in this study is the fact that when we get a little bit of sugar, we get a little bit of yum. When we get more sugar, our experience of that sweetness gets bigger and we have more yum, and more sugar creates a big yum, right? But the problem is then when we switch down to a lower sugar, our brain's a little bit disappointed. It's desensitized to this lower amount of sugar, and we're not even getting that little yum that we were getting initially because we got so overwhelmed and adapted to that very strong sugar sensation coming into our mouths. So the big question that we're tackling here is, where does this change happen? Where does the desensitization take place? So ultimately, both taste buds and brains play a role in desensitization. So first off, if sweet receptors in the taste buds are activated strongly and repeatedly, they can stop signaling as strongly. Then the taste buds don't release as much signal onto the nerve. Whereas in the brain, the signal from the nerve can also adjust and no longer be sensitive to the signal coming from the tongue. And if we go even farther into the brain, our brain can adapt to high sweet signals and then no longer experience as much pleasure in response to the same amount of sugar on the tongue. When we look at this from a historical context, we can see the problem going on within the amount of sugar that we're consuming here in the year 2020. So in this graph, we're looking at the sugar consumption per individual, that's on the y-axis, relative to the year from 1700 to 2000. And what you can see here is that there's a dramatic increase in sugar consumption per person over time, and that's continued into the 2020s here. So our tongues and our taste buds can adapt to this dramatic increase in sugar, and you'd think over time, with so much sugar in our diets, our brains are pretty desensitized to the amount of sugar that's everywhere within our diet. And it's kind of tough to readjust to that. And so you can see that it takes a little bit of time if you want to cut sugar from your diet. It's hard to do because you're so used to having so much sugar. So whereas our tongues and our brains are pretty good at adapting to this change in sugar, other organs inside of our body are not so good at that. And so, for example, the pancreas is not easily adjusting and can't handle the amount of sugar that's coming in with our kind of daily diets, and this could cause problems potentially related to type 2 diabetes. So it's no wonder when we compare diabetes prevalence to the sugar per person increase over time, it's no wonder that we're having so much diabetes and so many deaths related to type 2 diabetes when we have so much sugar coming in and our body just can't handle that much sugar. And so the idea here is that we're looking at just the fact that because our tongues and our brains are so good at adapting, the rest of our body is not capable of doing that. So to wrap things up, the big takeaways here is that we're really hoping that students ask questions such as, how does our sense of taste adapt to change? How can increased sugar in our environment lead to decreased perception of sweetness? And we really want them to learn and come away with the fact that humans are consuming more sugar now than ever before, and that exposure to high levels of sugar can cause this desensitization in the tongue and in the brain, whereas other parts of the body can't do that, and it's causing all sorts of problems, type 2 diabetes and pancreatic problems being kind of first and foremost of those diseases.